All right, we're going to be looking at exponential decay. So we have a word problem here. Let's read through it once and then highlight important information, and then we'll get to our exponential decay formula. Okay. It says the population of a city increases by 2% a year. That's probably going to be important. On January 1st, 2000, the city had a population of 530,000. What will the city's population be on January 1st, 2020? Okay. I'm going to highlight what I think will be important. Then I'm going to build a formula and pick stuff out. The population of a city increases by 2% a year. That's probably important. On January 1st, 2000, okay, so on this date, the city's population was 530. And the question asks, what will the city's population be in January 1st, 2020? Okay. Okay. We have our population is equal to P naught 1 plus our
Does
increase.
that dot have a value? Like you have to do something?
No, no.
It's just it's that little O. Like
yeah, and we could, we could start. Let's call it something else. So we'll call it our initial amount. So we'll say our original population, and we'll call this our future amount. You can really use any letters you want to denote anything. Okay, so we'll call this future population. So we'll write what they're going to equal. F is equal to our future, and I'm just going to write population as pop. Okay, P will be our present population. Okay, I is our you know what? Actually, let's call that R. I know I've written so many different letters already. Let's call it R for our
in this course.
Yeah, our rate of change. Okay, R is our rate of change in this question.
If it's future, this P is that P right there, right?
And N will be the number of periods, or in our case, because it's per year, we're going to say years. Okay, R is our rate of change, and really it's going to be. Oh, and I wrote decay. Oh, that was silly of me. This should be called growth, but that's no matter. I think I reread the question wrong. This is increasing. That's really important. So let's call this growth. Okay.
I really like this program.
So because it's increasing, that's how I know I'm working with exponential growth. Okay. And the addition here, it lets me know that it's growth. The only difference between exponential growth and decay is I would rewrite this exact same formula. I'll write it here. It'll disappear in a second. It's P, but I would write 1 minus our R or I or whatever letter to the power of N. Okay, N represents decay. Okay, in our case, we're growing, so it works out really, really well. We need to find values for F, P, R, and N. Okay, R is our rate of change. So what was this increasing by each year? What was the population growing by?
2%.
2%.
So that's 0.02.
Perfect. Great. So let's do R in red. Okay. So R is equal to 2%, which in our case is equal to 0.02. Amazing. What about our future value, F?
That you want to know.
Yeah. That's
unknown.
That's what we're looking for.
It's going to be in the year 2020 though, right?
That's right. And that's where our F is in the equation. Our R is here. What about P, our present population? All right, 530,000 people. Excellent. And finally, this one's a little more difficult. Okay, our N, our exponent. It's the number of periods, or in our case, the number of years that'll pass. So N is equal to.
530,000. It's a problem.
So what year are we looking for in the end here?
2020.
Okay, and what year do we start at?
2000.
Okay, so in order to find out N, we actually have to take our 2020 and subtract 2000. Yeah. And when we do that, you'll take a calculator out and try it. It's actually going to be 20. Okay, so we've just found that N is 20.
Oh, I get that, because 2020, and then when you take away that from it, you're just left with that 20.
Exactly. So now that we have all this info, okay, let's plug it in. F is our unknown, so we'll leave it as F. Okay. P in this case, our present population, 530,000. Okay. 1 plus our R was 0.02. And our N is 20. Great. So let's continue throughout this. F is equal to 530,000. we'll do our brackets first. This becomes 1.02 to the power of 20. So I got to do 1.02 to the power of 20 first. Now, you might be able to do this all in one step on your calculator. I'll do it one step at a time for us, hopefully. Let's see. The power of 20, what does that give us? A big decimal? It gives us a really big decimal. So instead of me writing that out, I know the next step is to multiply by 530,000. I'm going to do that in my calculator right now. So I'm going to take my answer from before and multiply by 530,000. There we go. That's equal to, and here's our value. So now I'm going to write that out. That is 787,552. F is equal to 787,552. And let's check our decimals and stuff. And we're going to talk about it. And technically it was decimal 1. Okay, so that's 787,552.1 people. Would we say 0.1 of a person? No, so we'd round this to the nearest whole number and it would round down. So this would be our value. The population in year 2020.
It wasn't over 5, so it's.
Yes, exactly. Yeah. So our population in the future, so let's say in year 2020, I shouldn't have capitalized that.
This makes so much more sense. What they were doing on the board, they were dividing 5 over something. And
this is a nice, easy way with that formula, right? 787,552 people will be in that town in the year 2020.